Good morning, students. So today we'll do another gas law which is called Charles law. These are the laws of gases. In last class we have done Boyle's law. So this is another law which is called Charles law. And this Charles law gives the relationship between the volume of the gas with temperature. So Charles law gives the relationship between the volume of the gas with temperature at constant pressure. So according to this law, at constant pressure, the volume of a definite amount of gas is directly proportional to its temperature. In Kelvin scale. I mean P directly proportional to T. Here T represent Kelvin temperature. So at constant pressure, the volume of a definite amount of gas is directly proportional to its temperature in Kelvin scale. So P proportional T at constant pressure and number of moles. Definite amount of gas means number of moles will be constant. So when you remove the proportional sign, a constant will come Kt, or you can write B by T is equal K. That means the volume divided by temperature always remain constant. If you change the volume from V to V1, temperature will be T1. I mean, when you change the temperature, volume also changes. Since it is directly proportional, if you increase the temperature, volume increases. If you decrease the temperature, volume also decreases. But when you do V1 by T1, the value remains same, constant. Or V2 by T2 is equal K. That means you can write V1 by T1 is equal V2 by T2. So this is the relation given by your Charles law. So in question, if volume and temperature is given at constant pressure, then you have to apply this relation. Q1 by T1 is equal V2 by T2. So in Charles law, you have got if temperature increases, volume also increases. If temperature decreases, volume also decreases. Now, with increasing temperature, how much volume increases or how much volume decreases with decrease in temperature, that also given by Charles law. According to Charles law, the volume of a definite amount of gas increases or decreases by 1 by 273 part of its original volume at 0 degree Celsius for every 1 degree Celsius rise or fall in temperature. Means, let at 0 degree Celsius, the volume is V naught. I mean, when the temperature in degree Celsius, 0 degree Celsius, the volume we have considered as V naught. If the temperature is increases by 1 degree Celsius like this, suppose from 0 degree you make it 1 degree, that means you increase the temperature by 1 degree Celsius, then the volume also increases. How much increases? It increases by 1 by 273 part of its original volume. This much volume going on increasing. Similarly, if you decrease the temperature like this, initially it was 0 degree, now you make it minus 1 degree Celsius. Minus 1 degree Celsius means you decrease the temperature by 1 degree, then volume also decreases, then the volume becomes V naught, 1 by 273 of V naught. So that means the volume of a definite amount of gas increases or decreases by 1 by 273 part for every 1 degree Celsius rise or fall in temperature. Now see, Here from 0 degree Celsius you make it minus 1 degree Celsius. When you decrease the temperature by 1 degree, then the volume goes to this much. If the temperature decreases up to 273 degrees Celsius, I mean from 0 degree Celsius it decreases the temperature up to minus 273 degrees Celsius, then what about the volume? Then the volume goes to minus 273 divided by 273 of V naught. Ultimately you will get V naught minus V naught, then the volume become 0. That means this is a gas. The container contains a gas and the temperature initially it was 0 degree Celsius. When you decrease the temperature up to minus 273 degrees Celsius, I mean from 0 you make it minus 273 degrees Celsius, you decrease the temperature, then what about the volume of the gas? The volume of the gas become 0. And this temperature at which the volume of the gas becomes 0, this temperature is called absolute zero temperature. This is called absolute zero temperature. This is in terms of degree Celsius, and this one I have given in terms of Kelvin temperature. Degree Celsius is represented by small t symbol, and Kelvin temperature is represented by capital T. So what is absolute zero temperature? Absolute zero temperature means that temperature at which the volume of the gas becomes 0. So volume of the gas becomes 0 means what about the gas? Actually at this temperature at minus 273 degrees Celsius, the gas will convert its state to liquid or solid state. So that's why the volume of the gas, because particle will remain there but the state will change, it may be converted to solid or liquid. So this absolute zero temperature is important. What is absolute zero temperature? Absolute zero temperature is the temperature at which the volume of the gas becomes 0 at constant pressure. So this is about the absolute zero temperature. Now I'll tell you one thing. At 0 degree Celsius, the volume V is equal to V naught. So at 1 degree Celsius, I mean when you increase the volume, then V is equal to what? V naught plus 1 by 273 of V naught. At 2 degree Celsius, again you increase 1 degree. What about the volume? V naught plus 2 by 273 of V naught. At T degree Celsius, what about the volume? V is equal to V naught plus T by 273 of V naught. So at T degree Celsius, if you take common V naught, then it becomes 1 plus T by 273, or V naught. If we take LCM, 273 plus T, this is degree Celsius temperature. Do you know 273 plus T? I mean when you add degree Celsius temperature with 273, then it will convert to Kelvin temperature, na? So ultimately you can write V naught into capital T divided by 273. What is capital T? Capital T represent your degree Celsius, Kelvin temperature. Small t represent degree Celsius, capital T represent Kelvin temperature. 273 plus degree Celsius temperature, always you will get Kelvin temperature. For example, 25 degrees Celsius. If you want to convert in Kelvin, just you add 273, so you will get 298. This will be Kelvin temperature. So when you add degree Celsius by 273, then it goes to Kelvin temperature. Now here 273 is one of the constant term. V naught means initial volume, that is also constant. Ultimately you can write V is equal K into T, because this one and this one is constant, I have written as K. That means you can write V proportional T, and that I have written here. So this is in terms of degree Celsius and this is in terms of Kelvin. I mean volume is directly proportional to temperature in Kelvin scale. So actually Boyle's law is this one. If the statement asks, you can write this one. The volume of a definite amount of gas is directly proportional to its temperature in Kelvin scale at constant pressure. And if you want to explain it in terms of degree Celsius, you can explain the also like this. The volume of a definite amount of gas increases or decreases by 1 by 273 at 0 degree Celsius for every 1 degree Celsius rise or fall in temperature at constant pressure. You can write like that way also. So you can represent it in terms of degree Celsius temperature or in terms of Kelvin temperature also.